Forecasting tsunamis is a different science than forecasting weather, but both are done by the National Oceanic and Atmospheric Administration. And NOAA's Hawaii-based Tsunami Warning Center went into action after last Friday's earthquake near Japan that was one of the 5 most powerful in the world since 1900. It was centered 230 miles northeast of Tokyo and produced a tsunami that propagated across the Pacific, eventually reaching Hawaii, Alaska, and the U.S. West Coast. Indeed, undersea earthquakes, especially those of magnitude 7 or greater, are the most common cause of tsunamis, and last Friday's was a 9. The vertical movement associated with such powerful earthquakes transfers energy to the ocean as a set of waves that travels hundreds of miles per hour in the deep ocean, where a tsunami appears as just a very gentle, nearly imperceptible bulge. But as a tsunami moves into shallower water near a coast, it slows due to friction, the water bunches up, and this increases the height of the waves. The tsunami generated by last week's earthquake reached the U.S. West Coast about 9 hours later, with the highest waves in northern and central California. Here's some of the maximum wave heights. All are on the order of 6 to 9 feet. Crescent City, California is one of the most tsunami-prone cities on the U.S. mainland, and about 50 boats there were destroyed or damaged. Now, to get a sense for what went on at Crescent City, here's a graph of the water levels before and during the tsunami, between 7 and 15 hours after the earthquake. That's in maroon, the water level at Crescent City. The black line is the average level. The blue line is the level based solely on the tides. Now, before the tsunami hit, the tide was going out, so the water level was dropping. And then you see the first tsunami wave arrive. The water level rose almost 3 feet in 10 minutes. It then dropped 9 feet in the next 20 minutes, the beginning of a wild oscillation that lasted for the next 5 hours and beyond. At times, the water level was changing at a foot per minute, with about a 13-foot difference between high and low water level. Now, the forecast did capture the height of the tsunami very well, but the timing of the individual waves was off, typically by 10 minutes or so. Forecasting tsunamis in real time is quite a challenge, given the variety of seafloor shapes near different coasts and the fact that each earthquake is different, so every tsunami has unique wave heights and wave lengths, the distance between wave crests. A real-time tsunami monitoring system known as DART, for Deep Ocean Assessment and Reporting of Tsunamis, plays a critical role in their forecasting. Each DART station consists of a surface buoy and a seafloor monitor that detects pressure changes caused by tsunamis. Data from this network is relayed via satellite to tsunami warning centers and ingested into computer models to produce the forecasts. That information is then used to issue tsunami watches and warnings, similar in intent to those issued for winter storms, tornadoes, and hurricanes. Fred is back with the extended forecast next.